So I'm going to show you 3 more examples from the even problems on section 8.6 in McGraw-Hill. So I'm give you a little bit of time just to write down the first one. I know watching videos isn't always the best way to do things, and I believe I'm going to hold a live lesson probably starting next week, maybe tomorrow. We'll see. Maybe I'll send out a short little form for you to fill out tonight and ask you if you think that's a good idea. So what we have now on example 8 here is negative 12 over y equals y minus 7. Now, we know that the denominator here is 1, so we don't even have to take that into consideration when we're looking for an LCD. So what that means is our LCD is just y. So I'm going to multiply the left side of the equation by y and the right side of the equation by y. Hold on, I'm off the table a little bit here. When I multiply the left side by y, the purpose of doing that is to cancel out the denominator. On the right side, well, that y has nothing to cancel out with, so it has to be distributed. Once you get to this point, remember we're solving a quadratic equation. That means set it equal to 0. I'm going to add 12. Look to factor, so minus 4 minus 3 equals 0, giving you these two potential solutions, 4 and 3. Because 4 minus 4 would be 0, which would make that 0, and 3 minus 3 would be 0, which would make that 0. Now, when you go to check these, the first thing you want to scan is the denominators. You do not want a 0 in the denominator. This would make a 4 in the denominator, which isn't a big deal. This would make a 3 in the denominator. So if you do the check and you want to write it out, you can. So there is the 4 equals 4 minus 7. And that looks to be true. Negative 3 equals negative 3. And for the next one, if I plug 3 in, that also looks to work. So these two solutions do work. Example number 2. I have two denominators. Actually the third, but it's invisible. It's just a 1. So that makes our LCD b plus 1, b minus 1. And you can see, I'm going to write it on the left side. You know, I sometimes get lazy with the parentheses. And I'm going to write it on the right side. And when I write it on the right side, we know it's going to distribute there and here. So I like to write it twice, so when I cross out my denominators, I can really see what's left. So I have b minus 1 times 3b minus 2 equals, I have the 4 times both of those terms. I have my minus sign, and then I have my b minus 1's canceling, giving me these two things. Now, this type of problem is a little harder because there is a subtraction sign, and we have a lot of binomial multiplication to do. So I'm going to FOIL this out. 3b squared minus 3b minus 2b, which is minus 5b, plus 2. I know when I multiply that out, I'm going to get this, because that's a difference of squares. So I'll distribute the 4 here. And if you're not confident about the step that I just did to multiply that out, feel free to show all the work. It will come out to this. Then I have a minus. And that FOILed is going to give me, and you can see that I left the parentheses because that subtraction sign is a real pain. It has to bring its way into all of those. So I have 3b squared. So I have 4b squared minus b squared. I have minus 3b. And I have negative 4 minus 2. And I know to solve this quadratic, I have to set it equal to 0. But I can see that's going to happen, so it's no longer a quadratic. I'm going to add 3b. I'm going to subtract 2. And I find out b is 4. Seems like a decent solution if I glance at it quickly. So for my check, I'll do some of this mentally. So I know 4 is my answer. 3 times 4 is 12. Minus 2 is 10. If 4 is my answer, 4 plus 1 is 5. Equals that 4 minus b plus 2. So 4 plus 2 is 6. Over 4 minus 1 is 3. So 2 equals 4 minus 2. Yep, that seems legit. So your answer is 4. We like that answer. Last example. The LCD is not all three denominators because this denominator is actually a combination of the other two disguised when you factor it. So that makes your LCD W plus 2, W minus 2. I'm getting a little lazy with the parentheses. Just know that those are all separate terms. I'm going to be crossing out some of them anyway. So I have 1 times this. I have 1 times that. Oops, I should have paid a little more attention to what was written there. But look what's going to happen. That didn't turn out so badly for me. So I did with W plus W, negative 2 plus 2, W equals 2. Can W really equal 2? No, that'll produce a 0 in the denominator. The answer is no solution. Hope you enjoyed.